Dear friends, as we know the definition of Laplace transform, we are going to see the table f of t. Laplace transform of f of t is f of s. We already know the definition. So Laplace transform of e raised to kt, that is given by 1 upon s minus. Laplace transform sin kt is given by k upon a square plus k square. Laplace transform cos kt is given by s upon a square plus k square. Similarly, there is a hyperbolic function like the sine and cos are circular functions. So for hyperbolic function, sin hkt is Laplace transform is given by k upon a square minus k square. K is s is greater than mod. Fifth is Laplace transform of cos hkt is hyperbolic function of cos, that is given by s upon a square minus k square. So these are important result. And last result is t raised to n. If n is equal to 0, 1, 2, dash, then its Laplace transform is given by n factorial upon s raised to n plus 1. Last is if in general n is instead of integer any other number. So for fraction type it is t raised to n, its Laplace is given by, or Laplace transform is given by s raised to n plus 1. Let us, we already took some example, but also we discuss their properties. These are the Laplace transform. That means it converts function of t into function of s. In previous lecture, we observed the Laplace transform of discontinuous function. For example, problems on definition. You can see this topic is problems on definition of Laplace transform. First problem, find Laplace transform of f of t if f of t equal to e raised to t 0. If t is like between 0 to 1, then Laplace transform f of t is, sorry, value of f of t is given by e raised to t. If t is strictly greater than 1, then its value is 0. How to solve this problem? Solution. We have to use the actual definition. Laplace transform of f of t, that is given by 0 to infinity, integration from 0 to infinity e raised to minus st f of t dt. Here we are given the function defined on the interval 0 to infinity, but that is break into two parts, 0 to 1 and 1 to infinity. So from this we get the inspiration. We have to break this integration into two parts. Here t lies between 0 to infinity, means t 1 to 0 to 1 plus 1 to infinity. Separate integration. You can observe value for if t lies between 0 to 1, f of t having value is e raised to t. So just substitute e raised to t, and value for f of t, if it is lies between 0 to infinity, its value is 0. So this integrand value will be 0, because integration of definite integral is 0. So simplify this, e raised to minus, taking minus outside and t outside, integration of this, that is given by here minus outside, then it will be here. I made mistake. Here just take the t outside, don't take minus. Integration of this is given by 1 minus st upon 1 minus 1 minus s is constant, taking outside. Just substitute the upper limit of t. Upper limit of t is this. We can here again there is a printing mistake. I made one mistake. Here limit of t is 0 to 1. So here not infinity required. Here it is t varying from 0 to 1. So just substitute the upper limit t equal to 1, then e raised to 1 minus s minus t equal to 0. E raised to 0 means 1. So in this way we have to solve such type of problem. This problems on definition of Laplace transform. Now next is, we already studied linearity property. Like a derivative also holds linearity property. Laplace transform of f of t plus g of t, that is given by Laplace transform of f of t plus Laplace transform of g of t, and Laplace transform k into f of t, that is given as k into Laplace transform of f of t. Now we take some examples on shifting property. You can say first translation or shifting property. Means if Laplace transform of f of t, that is given by say f of s, then Laplace transform of e raised to at f of t, that is given by f of s minus. Means if the function can be break into two parts, one is exponential part, one part, another is function of t, whose Laplace transform is f of s. Then Laplace transform such type of function is given by f of s, but replace s by s minus. So we can also write this is as a Laplace transform e raised to minus at f of t, that is given by s of f of s plus. Now we take the problem on this. Like a derivative chapter. In derivative, we first solve problems on definition of derivative. Then we solve problems on formulas of standard functions of derivative. After that, we studied some properties of derivatives like product rule, quotient rule, addition rule of derivative. Product rule means derivative of u into v. Quotient rule means derivative of u by v function. So in such way, in a similar way, here we are going to study properties of Laplace transform. That's why we have started this topic. So we can give the name properties of Laplace transform. Proof is also important. So first we go through proof, then we start problem on this. So this is first, and this is second. So already we know Laplace transform of f of t is given by 0 to infinity e raised to minus st f of t dt. We are interested to show the value of Laplace transform of e raised to at into f of t, that is this. So consider Laplace transform of e raised to minus at, or say first of all plus at. Since we start first problem, so here Laplace transform of e raised to at f of t. So by the definition of Laplace transform, just replace f of t by this function. So e raised to at f of t dt. See, here f of t was there, so I put it this one, and here work of f of t, that is carried out by this function. That's why I have to replace this one. So simplify this, e raised to minus s e plus at, use the law of analysis. One thing you note that Laplace transform of f of t, that is this integration, and its value is given by f of s. Means Laplace transform of f of t is f of s. Now 0 to infinity e raised to, remove the t outside. So yes, taking minus also outside. Yes means. And if the Laplace transform of, note that we know integration of e raised to minus, yes, yes, that is written in this way, f of t dt, that is given by f of this is. So here, what is s in this problem? Our s is this. So on same line, we can write f of, what may be there, instead of s minus 1. So in short, Laplace transform of e raised to at f of t, that is given by f of s minus 1. Similarly, Laplace transform on same line, Laplace transform of e raised to minus at f of t is given by f of s plus. Now we take problems on this. Problems on property 1. Example, find Laplace transform of t cube e raised to minus 3t. Second is Laplace transform e raised to 4t into sin 5t. So observe that your given function can be break into two parts. One part is e raised to some means exponential function, another is function of t. So this can be written as, for first problem, e raised to minus 3t into t. So apply the property. Just take here e raised to at. E raised to at means e raised to minus 3t. So or we can apply second property also. Second property also obtained from first property by replacing a by minus a. So we get this. So we know Laplace transform e raised to minus at f of t, that is given by f of s plus a. So here a equal to 3. What is f of t? F of t is t cube. What is f of s? F of is nothing but the Laplace transform of f of t. That is obtained by taking Laplace transform of t cube. And it is given by Laplace transform of t raised to n is n factorial, is 3 factorial upon s raised to n plus 1 is 4. So f of s having value 3 factorial upon s raised to 4. And what may be the, we require f of s plus a. What is f of s plus a? F of s, and we replace s by s plus a. So Laplace transform e raised to minus 3t t cube is equal to f of s, and replace s by s plus 3, because here 3 is there. This 3 Here it is. But what is f of s? F of s is nothing but the 3 factorial upon s raised to 4. S is replaced s by 3. So we get answer 3 factorial upon s plus 3 raised to 4. So this is your final answer. If you want, you can simplify this. This is as a 6 upon s plus 3 bracket raised to 4. So in this way, we are solving this first problem. For second, here again this function split into two parts. One is exponential, another is sine phi t. So Laplace transform e raised to 4t into sine phi t. Here to use Laplace transform e raised to at f of t, that is f of s minus or f of s, and replace s by s minus 4. Here a equal to 4, f of t equal to sine phi t, and f of s. How we can obtain f of s? By taking the Laplace transform of f of t. Laplace transform means sine phi t. We observe the formula Laplace transform sine phi t, that is given by 5 upon s square plus 5 square, because Laplace transform sine at, that is given by a upon s square plus s square. So in this way we obtain f of s. We know f of s. We also know a equal to 4. We also know this property. So just replace s where s is there, raised by s minus 4. So Laplace transform of e raised to 4t sine phi t is given by f of s, and replace s by s minus 4. But what is f of s? 5 upon s square plus 5 square. We have to replace s by s minus 4. 5 upon s minus 4 plus 5 square. After simplifying, we will get 5 upon the plus 25. 5 square means 25. And for this, s square minus 8s plus 16. So in this way, we use first property. We also took the proof of this first property, and here again remember that this is obtained by replacing s by s minus 4. Replacing. So in this, there are again some more properties. Multiply by t, divide by t, like this. Second shifting property also we are going to take. So up to this, We stop now. Thanks for listening patiently. Thank you.